All right, here we have our test system and we're running it at stock speed right now. 3570K running at stock speed is 3.8 G. And we're measuring the power consumption of the motherboard, which is feeding the CPU, to get an idea of how much power it's consuming and how much heat it's producing right now. So we want to see how good the stock heatsink is doing. All right, as you can see, we're using links to push the CPU to its limits, getting it really hot. We have our 3570K here, Ivy bridge, running at 3.8 gigahertz, so it's stock speed. And you can see that we reach temperatures up to 87 degrees with the stock heatsink at stock speed already. Alright, and we're back. We just rebooted the system and overclocked it to 4.2 G. It's running at 1.3 volts now. And you can see that after only 4 minutes in links, we're already hitting 104 degrees on one of the cores and the CPU throttled. So the CPU reduced its clock speed because it was getting too hot. Now we have the same system overclocked to 4.2 G with Seidon installed, and you can see that we're getting temperatures that are much lower than before. With the stock heatsink we're hitting up to 105, now we're 70. We've already run links 3 times, but we can't get it to break 70 degrees, so it's 70 degrees is the highest. And you can see that with Seidon we're struggling to break 70 degrees. So the center cores are both hitting 70 degrees, but this is the 4th run of links and we haven't managed to break 70 degrees, while the stock heating was hitting 104. We went a step further this time and went back to BIOS and chose the profile for 4.6 G. And the links test just finished, and you can see that with 4.6 G and 1.35 volts, Seidon is still able to keep the CPU below 77 degrees, or at 77 degrees, which is pretty good for this high of an overclock. Now we're going to try and see if we can do that with 4.8 or even 5. And as you can see, it's working. We're now up to 4.8 G, and this is the second run of links. Seems to be stable so far. We had to increase the voltage a little bit to 1.4. But it's stable, 86 degrees max, so pretty good. Unfortunately, 5G is out of reach. We tried it, but it wasn't stable. But 4.9G does work with 1.5 volts, which is a little bit high, but you can see it's stable. We're getting temperatures of 95 degrees, up to 95 degrees, but that's still 10 degrees better than the stock heatsink that couldn't even run the system stable at 4.2G. So the sweet spot of this system is probably around 4.8 with a little bit lower voltage. And then there's plenty of headroom to reduce the fan speed and make the system quiet and have it stable at 4.8G. One more thing, here are the BIOS settings. You can see that for the latest run, 4.9 gigahertz, we used the 4.6 profile that's in BIOS and manually adjusted the CPU multiplier to 49 and increased the CPU voltage to 1.45. The only other setting we changed is the, where is it? Advanced monitor, fan speed control. We disabled the Q fan, fan speed control to set all fans to maximum. That's about it. Those are all the settings we used. We wanted to show you what Seidon can really do, so we installed it on our Socket 2011 system, and we have a 3820 running at 4.6 right here. And you can see that power consumption is pretty high. It's the current reading right now shows 19.2 amps with 12.1 volts. That's over 200 watts for the CPU, around 210 watts for the CPU. And Seidon is keeping it at 79 degrees for the hottest core, so it's doing pretty damn good.